All right, so now we've done the one sample test, one population test, which we also use for the two sample dependent, of course. Then we did the two populations, dependent and independent, where we test hypotheses about their respective means. Now let's look at the more general problem when we've got more than two populations. There are a number of things we can do, but I just want to concentrate on this simple one where we want to test the hypothesis that all the means on all the populations are equal. So the one hypothesis that all the means of the k populations are equal. Okay, so we've got k independent random samples. So schematically, we could say, all right, we've got this population 1, and we're going to take a sample from this population. And so there's the sample, and the sample size from the first population is n1. We'll calculate the sample mean x bar 1, and we'll calculate the standard deviation of that sample. And there it is. Then we will do the same thing with population 2. We'll do the same thing, population 3 and population 4 if we have 4, and so on to all k. So for each one of these, we're going to have these samples and do these calculations. So there are the populations with means mu1 through mu k, standard deviations sigma 1 through sigma k. And the null hypothesis is that all these means are equal to each other. That's the null hypothesis. Now, in order to do this bigger problem, we are going to make some more restrictive assumptions. We're going to assume, first of all, that all the populations are normal and that we are in the homoscedastic situation. So all these k standard deviations are equal to each other. And the third assumption is that these samples, all k of them, are independent of each other. So it's not the before and after situation. That's the problem we're going to be faced with. Now, what I'd like you to do is step back a little bit and think how you would solve this problem. This is the hypothesis you're interested in. Now you know what the data are that you have available to you, and we've studied the techniques with one sample and two samples. How would you expand that to answer this question? Are all the means equal to each other? So think about that for a little bit and then come back.